which is wonderful for us because that way we know what's going on in other places. And we are very happy to welcome Gonçalo. Gonçalo is a graduate of our school, so he got a PhD from Faculdade de Arquitetura 2 years ago, yes. And before that, he has a master's from Barcelona and a bachelor's degree in licenciatura from the University of Porto Faculty of Architecture. And we are curious to know what he has been doing since then, so I'll give you the stage.
Thank you, José.
Thank you for doing this.
The pleasure is mine to be welcome and to be back home. So thank you for the invitation, and thank you all for being here. I know this particular time of the year you're very busy, so that's something I would like also to thank for your presence. So I will speak a little about my presence in the past 6 months in Brazil, in the Universidade Federal do Rio de Janeiro. I currently teach there 2 disciplines, and beside that I work with the laboratory that is called LAMO, and that I will present to you. That is a very young laboratory, but also in my perspective very interesting, and so I can share a different framework or a different reality to most of you. So this is the LAMO, Laboratório de Modelos e Fabricação Digital. So I will just start by a short description of the activity of the laboratory, and then I will talk about the focus we have and about what we are doing, highlighting 3 different moments that were important in the studio. And the background there in Rio is that the school is in a campus out of town, and from the 50s to 2000 we had a model workshop, but was only used to do models, but it was an elective course. It was not on the curriculum, let's say, on the major. And then until 2013, it was almost without use, and so one person, in this case Andrés Pássaro, that is professor there from Argentina, he reactivated this space with a renovation of the space. This was the look before. Then there were a lot of models that were a little more like picturesque kind of models to represent the project as an end process. And this is already when the workouts began. There was nice material, the space is big, and it was not so well used. And also there were these machines that are mechanical Saint-Shaw, different kind of machines that were not in good shape, but they gave a general increase. They also cleaned the space and prepare it for other tasks. And then there was this important moment, like in a little here happened. We know when this laser cutter comes. In the beginning, everyone is suspicious, and then everyone wants to use it, and it becomes very, very active. And then at the same time, some students' initiative began. And so this was one of the first, and of course it was without digital fabrication. For example, this was with pallets and some kind of installation. And then other workshops like this one with a professor from Uruguay. And it's in my perspective is interesting that they wanted to test different forms, but in a way very analogic. And here, for example, when I look at this, I imagine using 3D printing. That's what we are doing now, but The story of the laboratory, I think, is different because of this background in analog, let's say, model making. This is also from this workshop. And then actually the official foundation of the LAMO 3D was after this workshop with Andrés Pássaro. And 2014, I started also the collaboration with LAMO. At the time, I was not in Rio, but I was invited for this workshop that it was very important for the university, for the workshop. Sensitive shelters, and I will also talk a little more later. And this was also an opportunity to join forces with the fine arts laboratory called Nano. These are some images from this workshop. Then other courses started there, like for the students with 3D printing, and also to assemble their own machine. That was funny. And courses for students. The policy of the university, of LAMO, they started to have assistants, and then the assistants, they teach to the students, so it's not for only graduated or post-graduated, so it's open, and the policy is to make them everyday use, and so they feel comfortable using these technologies. And this is some of the messages they were changing. The laser cutter became very active, and so I think these are part of these communications. And also the laboratory tried to attract other conferences, like this one from Montaner, and another workshop with MIT. It was a torus, double curvature formed, and it was a good challenge for them also. Here we can see some of the interior spaces. And 2015, we had the wiki-house, or the name there is Casa, Revista. There is this opportunity for the fabrication and construction of one-to-one building that I will also talk a little more after. This is the arrival of the material for the wiki-house. The fabrication was done by students in a commercial factory, because the university has no facilities to do that. So we did this first building without facilities, but with agreement with local firms. So this is this was done during the holidays. Took 2 months, and the construction were more or less 2 weeks, and it was also done by students. One characteristic that is here, I think you talk much about agency. There we have a different agency. There is a lot of people interested and motivated to work. So it's also something we could use, or this is a characteristic. So this is the wiki-house that I will also talk a little more. And one thing that is common is, like, some students, they propose workshops and they do it. Like this one, Sentai, is to build chairs, and they make their proposals, and they also apply for a competition. This is a student from design, for example, in this case, that gave this workshop. And we just had a little time ago Bernard Franken, one of the digital pioneers that we already had in Porto and here in Lisbon. So it was nice to hear his version about this digital story as one of the, let's say, first movers into the digital. And recently we start with some courses of Grasshopper. And one of the last moments was the Defying Gravity. That is a workshop that I will also talk a little more. Here are some images of this Defying Gravity and of the people there. And another moment I would like to highlight is this exhibition included in CAD Future that is called Homo Faber. And this was a cartography of the digital in Latin America, fab labs, fabrication laboratories, of course with the digital, but that was an important moment to understand the particularities and how people are working there. I guess the fab labs in South America are around 40. They have different characteristics. The great majority of them is in Brazil. They have now a strong network, and that they want to increase. LAMO was presented there. I was presenting, actually I was presenting LAMO in this conference in CAD Futures, and they differentiated the fab labs. I mean, them is Pablo Herrera and David Sperling. Pablo Herrera is a long-time contributor of Sigurati, and so he has been talking about how the digital is growing in different countries in Latin America. So he knows what he's talking about. So he was talking about information surfaces, information objects, informing spaces, informing social processes. So this was some categories he chose to qualify this or to identify different spaces. Most of them are very young in age, and most of them from 2010 to now. It's their story. With LAMO we started in 2012, and these are some of the what they are doing. Some design prototypes, models for heritage or pedagogical objects. Some, but not so much, are doing the components for the industry. Other different types of objects and museology and some machine invention. So this is the state of the digital fabrication in Latin America, let's say. So now I will talk a little more about the lab itself and to tell you about the different approach and our goals. And so I will differentiate three different stages in the laboratory. I will start by the background. The background, as I told you, from the 50s to 2000, there was this physical model workshop with only elective disciplines. So there was this mechanical hardware, a circular saw, hack saw, bend saw, belt sander, and the space was disabled in 2000. He was, in a way, refounded in 2010. It was refurbished and machine selection and some maintenance, but actually it only started in 2013. But these three different stages I will talk, they are different because here, for example, they started doing fabrication without learning digital CAD. So most of the students, I will show this first example is a wiki-house. Most of the students never draw in the computer, but they started to use CNC. So, and they do it on vacations to produce the house. So this is I would say the Brazilian, and especially in Rio, they are very creative, and this is a good proof because they wouldn't do in the as we are used to, or learn first to draw, then the relation with drawing and cutting. So they jump, and they started the first phase of the laboratory was the fabrication, and so I will show a video about this. No. Seria.
Posso vir esse Skype e tentar desenvolver som aqui.
Não está lá.
Isto tem que ser. Yeah. Música ou era locução?
Era música, mas não está. So some technical problems, but I will talk a little more about the experience itself. So as I said, there is a young and enthusiastic community that is very interested in this digital experience. So this wiki-house, for most of them, they never built anything in the university. So to have this wiki-house, that was the first wiki-house in Latin America, and it was the biggest in size that the wiki-house built, was really an interesting opportunity. As I also was telling you, they had this experience without few digital experience on the CAD side. So in a way, this is also there is also a big challenge to improve. For example, this construction by improving the connections, by the number of pieces we use. But I guess for the first digital manufacture building, it was quite a success. And it took more than, they took two months in during the holidays. I was not there at the time, but then when I arrived Rio, that was in February, I was lucky to be in time to coordinate the team and to also build the house. I guess this is something that digital enthusiasts or digital fabrication enthusiasts, I would say, they like to build and to test these things, and they use the digital as a way of proving and testing their ideas and their projects. So here we see the interior. Then everyone in the laboratory was doing a different furniture for the house.
The people were not 3D printed.
Yeah, there is a cat. Yeah, here's the cat. Here are the chairs. I guess this video is without sound because I had a larger one, but this is the shorter version, so I guess the sound should be working. So this one, this video doesn't have the credits. I just have to say it's a big team that I have been included, and I guess that was part of the magic of the experience. And then about the second moment in the laboratory, and this moment in a way is connected with the other one, or they are not sequential. So this other moment, we started with a workshop that I will show to, that is called sensitive shelters, abrigos sensíveis. And this workshop, they start to use also the CAD and the digital generation of project. So
E a ideia surgiu mesmo de movimentar um pouco o que estava acontecendo na FAO, trazer os alunos para dentro do laboratório e fazer com que eles mexessem, aprendessem e vissem a gama de possibilidades que existem trabalhando com fabricação digital. A gente, na verdade, resolveu estruturar o workshop em 5 grupos que trabalhariam com mecanismos já um pouco pré-definidos, mecanismos de abertura. Eles teriam que criar um espaço onde houvesse uma interação entre o objeto construído e o homem. Então, na aproximação do homem, aquele espaço deveria responder a ele. A gente tinha os mecanismos, eram 5 mecanismos que cada um ia tratar, e cada pessoa usou livremente o que sentido do povo era para eles, tanto que eles saíram desses mecanismos propostos e foram para coisas diferentes, como origami, formas tipo uma planta carnívora, e aí isso ia tirando outras ideias, outras possibilidades. A arquitetura se afastou, de certa forma, acho que do construir, né, do processo de construir. Então, a fabricação digital vem trazendo isso de volta, assim, né? Ele está próximo do projeto que ele está gerando, que ele está desenhando. Então, eu vejo assim, o Abrigos Sensíveis para mim foi isso, foi uma retomada, né? E não só uma retomada do projeto, mas também fazer com que esse projeto tenha alguma coisa de diferente, né? Que é a questão da interação. E eu acho que, no final das contas, a união do LAMO e NANO é uma outra quebra também de muralhas, sabe? De união de FAO e EBA, de união de Escola de Belas Artes e Arquitetura novamente, né? Que antes a arquitetura nasceu da Belas Artes e agora a gente está reaproximando. E o NANO com uma pegada muito mais artística e tecnológica, trabalhando com robótica, eletrônica, interatividade, trouxe para a gente também uma visão, acho, muito mais sensível da coisa, né? A gente normalmente tinha uma visão mais, sei lá, pragmática de arquiteto, de material, medidas, desenho, objeto estático. O NANO trouxe para a gente uma visão do calma aí, por que estático? Por que não mexer? E o homem? E a relação dele com o homem de uma maneira mais dinâmica, né? A nossa relação com eles acabou trazendo essa sensibilidade do olhar, assim, sobre o objeto arquitetônico e o próprio usuário.
So this workshop called Sensitive Shelters is also a collaboration of different teachers from different countries, and also is on my field of my PhD, that is responsive structures. So in a way, they had to go beyond the kind of works they do, because they had to think about a shelter that would react to the human presence. So they have also they learn about how to use sensors and to use different ways of inputting data to a structure that will react in a way. So in this case, we predefined some different type of movement, so that it will be more doable, let's say, in these 10 days. So they learn a lot. It was a lot of information, so we made this choice. And we are happy with the results. I think they are very good, especially in the context we are talking about. And so this was one of the highlights of this second period. And the third period is a period that we are now starting, I would say, and it's about the digital integration in all the phases of the design process. And is also related with a workshop, And this I also have to tell is like currently in Rio there is non-discipline that is part of the curriculum that is about digital. This is a total surprise, but at the same time it's a really good opportunity because in a way the laboratory is the heart of the university that everyone they come from the side. It's not on the main curriculum, but people are very interested in go there, so in to learn, and they have at the moment these opportunities that are more related with workshops. I will also talk a little more about the future that we want to change this, of course. I also teach there 2 disciplines, and they are about models and project, and they are totally done without computation, but we have the facilities, and we hopefully will have more knowledge. The other workshop, one thing I forgot to tell is about this bottom-up collaboration of the people that join LAMO. They work very well in team, and they make this magic that is in creativity happen. And then, so I will talk about this 3rd workshop, and this workshop we were talking with them about more systemic and integrated vision. We were interested in not to have an isolated object that is reacting, but more a system that is there are parts that are interdependent and that they react. So we wanted to give this inclusive vision, and also the digital becomes more familiar by being in all the phases of project as tool, materials, and process, so they could do project, simulation, and digital fabrication. So this was the last workshop. I have a short video because it was really 1 month ago, so we don't have the full video, but I mean, the projects I cannot show them so well, but I guess this will show you a little about the environment and the university. So defying gravity was also a workshop in 10 days with including two laboratories from the fine arts and from the LAMO. And the students were working in groups, and they had different starting points as structures that will defy gravity. The 20 students, 4 projects. It was interesting that 8 teachers, giving them knowledge in different areas, and this was successful to have so many people collaborating. I was not so used to have 8 people teaching in workshops, so you need more coordination, you need more teamwork, and I see this as a positive outcome, also this learning process. So this is a little the environment process, and about the laser, the 3D printing for many parts and of the project. These are some of the tutors and the students. They were talking about their experience there. And this is Andres Pássaro, the coordinator of the lab. So maybe in another opportunity I could speak with you more about the project themselves. I guess they are interesting, and they would explain a little better what I'm telling. But so future for the future, we have just one Nidital. I don't know the announcement for a robotic arm. We'll have actually 4 robots. One is a bigger robotic arm, and the other 3 are smaller, that they can collaborate. Actually, it was interesting because the Fine Arts is a partner, and they were more interested in this coordination robotic arms, and so we'll have both. We'll have new research lines because they were not so defined. I'm also working with them on this. I propose new graduation disciplines or electives, so they can learn these things in the university that they don't do, at least it is in the laboratory now. So we are also interested in doing a network, and I guess this is part of common culture in I see in the digital in Latin America. Sigradi is very successful in this, so people from different countries they are working together, and they know they need this to advance. So I guess this is also a change from the previous generation of the autosufficient architects. So this is, I think I see this as good improvement. So our robotic Centro Avançado de Fabricação e Instrumentação Digital, CAFE. And this is our team. Andrés Pássaro is the coordinator. I'm helping him more directly. But I would like to highlight that none of the team members has dedication exclusive. At the moment, none is paid for doing that. And but there is a really strong enthusiasm. Most of the students, they are still doing the graduation courses of the team, but recently they just finished, but they try to keep in the team. We'll see about how the process evolves, because we want to look for a more formal structure for the laboratory, but bureaucracy is really one thing that is really difficult there, but we'll manage somehow, I hope. So these are some of the entities that we are working, the NANO, FAO, probably with the postgraduate studies, with CAPES, with CNPq, that helps science in Brazil, and also with the state FAPERS entities. So thank you very much. I expect you to have some questions.
I don't know if anyone wants to step up.
Who is the first?
Gonçalo, so first of all, thank you very much for showing us what we have been doing there and how we have been working and things that we have been trying to do. I found it very interesting that we started with CAD. CAD came afterwards because it's very unusual. Usually it's the other way around.
Mm-hmm.
But I have to say I'm very impressed
Mm-hmm.
with the things that you have been doing at the lab, usually the other people at the lab. Because I think they were really interesting projects. The wiki-house, the other one with all those mechanisms, now with the robotics and so on. And I also find it interesting that you managed to do this without having the courses as part of the curriculum. So I would like you to explain a little bit more how that works.
Yeah,
because, in curriculum architecture, there are no courses on digital design or digital fabrication or
how? No, the magic and part of that, I would say that is one thing that I was looking forward is that Brazilian, I would say, and Cariocas especially, they are very creative. So they are used to work without the facilities and to do creative jobs and to do their things. The other thing is like sometimes when you banish discipline from the main courses, on the other side that opens a side door that sometimes it's much more interesting. So they come from the side door and they go to the laboratory. Actually, the laboratory is one of the most active parts of the university. The university is very big in space and has a lot of potential. And so I guess this is the
But that means that your work and the work of other people is done in addition to your
yes.
mandatory work.
Yes, my mandatory.
Students, this is done in addition.
Yes.
Okay, well, maybe you should do the same thing. You make it for students and it's more interesting.
Yes, because my actual, as I said, I'm not paid to do this at LAMO, but that's what I'm more interested. But I give two disciplines, and they are about project with models, and they don't use digital. And this year, of course, I would like to change that. But as first semester, I was just learning and to see what is their method. It has also a good thing that is they are used to think about analogic way of building models. They are. This is something that maybe we lost a little about this relation with the matter, and so that maybe that's also something that increases their potential or their creativity. And so I guess this is the situation. It was funny because in CAD Futures I was talking with the president from he's Dutch. And when I told him there was no course with digital fabrication or design, he couldn't believe. So by looking at this, I see that we have a good way. We want to a good opportunity. I mean, so we are now trying to give these other disciplines, so it becomes more natural. So that's where we are standing now.
Any questions from the audience?
Eduardo?
First of all, it's very useful, interesting, but especially useful to make good advertising or good promotion and dissemination of what you're doing.
Thank you.
For example, these videos that you make are very compelling, and I guess that's something we could learn from, because I think, for example, here in our laboratory, there's a lot of things that are done, and they keep the only product is the thing itself. And it would be useful, especially for us, to make videos and make more publicity of it, because it's very. When we see your videos, the idea is like, okay, let's make something similar. I would like to have participated.
So you're all invited to next workshop that will be next year. So please come to Rio, this wonderful city, and
Because it's important to show people what is being made inside the university also, because especially, for example, you guys make wiki-house. The wiki-house is something which is very visible. I guess it's the best invitation card for the laboratories.
yeah, a lot of people want to hire or to. I want to stay. To what's really nice. Can I pay to do that, or because it's right in front of the university? That's a funny situation. Well, thank you for the nice words. I guess I see also a difference here from when I left. So now you have a formal group, and you have a better communication. I would say that what is different there is this bottom-up collaboration, because, for example, for us, these videos, we also have the fine arts inside the university, but we send a message for interested people, and they come. There are many, because the number there is different. And then, as I was telling you, we even for the workshop we have more tutors, more teachers that I'm used to. So the dynamic is different, and also. I guess this is also part of the youngest generation. They have another vision, and they think about how important it is to promote their work and to show and convince the university, because they still have to convince the university. So even to assemble the wiki-house at the beginning, this bureaucratic process to talk to the director, maybe, I don't know, is it safe? How long is it going to stay? So is
Would you say that, so there are two reasons. Maybe one is because there's more articulation amongst departments in the faculty?
no, the students.
No, just the students.
The students and the people that organize it.
So you get the architecture students or the art students, and this is something that is useful for the promotion, or you think it's more because nowadays everyone needs to use their cell phone?
No, I guess the way of working that is different. People, they work with a bigger number and they collaborate. So the guys from the photography, they want to do this because it's an opportunity for them. But this also, there are good communication to know where these people are and you can also follow our work at the Facebook page of LAMO, and so it's common that we are doing a workshop. Team that wants to do the video or wants to work with us, and then they send proposals, and then we work on that. But this is something that comes from the laboratory itself and from the people that are organizing workshops, because university itself it's much more closed, and we don't have much support from the departments. So maybe because, as I said, it's something that is outside the main curriculum that gets so interesting for the students.
My question is, thank you for the presentation. I expect most students already volunteer and then they do give after 1 week. They have lots of courses to do and they are overloaded with work on those courses. So my question is, how does it happen in your school and if all these students working, I suppose, for quite some time in this project?
Well, in fact, they had turns, and also we had a strike on the middle, and that is another characteristic that you can never know what you're doing tomorrow as a professor, because this semester I first had the maintenance strike, then I had the student strike, and then that it was not so clear if it was a legal strike, and then so after there was professor strike, and then we had to vote in the university, and we used a way of voting they called the Portuguese way. I was asking which Portuguese, my God, and this was by standing and putting your hand up, and we had like 500 teachers, and 245 were for the strike, and 235 they were against. But nobody asked to count the votes or with a 10 votes difference, and so we are still on strike. I'm not sure if the period is already over or when the next is going to start. So creativity, I guess it's all these things.
One thing that I like very much about your work, both as a teacher
Mhm.
and learner, that you could see already really, really good is you have a soul of an architect. It's true, you have a soul of an architect. So you like to make things, you like to design things. And your field was very practical.
Mm.
Well, you have obviously theoretical frameworks,
Mhm.
theoretical frameworks, but you have to do something.
Mhm.
Here we can see you continue being the same, which is wonderful.
Thank you.
And this idea of making things happen, which I think is a wonderful way to showcase, the potential of these
Mhm.
technologies. I like that. Congratulations.
Thank you.
Okay, thank you, Gonçalo. We will move on to our second speaker, Interestingly enough, they come from the same school. This is just a coincidence. Juarez got his PhD from Rio, from the Federal do Rio de Janeiro, but in civil engineering. But he's an architect. So it is an interesting case and rare, to my opinion, that he has a Slovan architect and Slovan engineer as well.
Good.
So he was not afraid of doing, tough stuff concerning population and so on. So I was very impressed with the work. He spent some time with us, I guess, 6 months with us. Because he was interested in using shift grammar in research. I won't tell you the story because I want to tell the story. So, Boris, thank you so much. And,
thank you. I will just add that the
so you
university
from there, right?
No.
It's a big school, I think.
I guess the faculty here in Lisbon is, I don't know for how long, but it's developing also a good interchange or with a good collaboration with Brazil in general, I would say. So I would also open the door so this increases.
Yeah, but now I'm in Campinas with the Celani.
Oh, I didn't know that. Good for her. So you are in Campinas?
Yeah.
Okay, I didn't know that. That's a really help. Okay. She's smart. She's very smart. And a very good girl.
And she did a wonderful job in CAD Futures also.
Isto aqui é mais simples, é pôr no bolso. Podes pôr no bolso mesmo. Desde o momento que a antena fique ou assim,
Ok, assim.
lá para dentro.
Ok.
Assim, se der jeito, está bom assim.
So, thank you very much, Professor Duarte.
Acho que está desligado. Não, está ligado. Obrigado.
Thank you very much, Professor Duarte. It's a great pleasure for me be here and see Professor Leitão. 10 days ago, we are in São Paulo with in CAD Futures. And today I present these works in a civil engineering congress, the same works. Being architecture engineering is a creative, logical, and stimulating task. My experience in civil engineering forced me to start with simple things and improving complexity. My work has two scales, always in optimization. The first scale is optimization of single members steel members. And second scale, optimization of structural systems. 3 years ago, I started this work with set grammars with Professor Duarte, and now you have some news. Optimization of steel members, open sections, has some stages, interesting stages, because there are some topics to consider. There are mechanical topics and manufacturer topics to understand in this process. In general, optimization of steel open sections consider only mechanical topics. We can achieve a very good choice for mechanical, but bad choice for assembling. It's very important to understand the manufacture process to optimize a steel structure. We have international guides that provide the strength of the shapes, and some softwares that help us to provide strength of unusual shapes. But until working with Professor Duarte, there is no algorithm to generate only manufacturable shapes and estimate this strength. My work is to work of dissemination of set grammars in civil engineering. It's not a common approach in civil engineering. It's interesting for them. Shape grammars is useful to design from cafeterias to aircraft components. In my case, structural systems. For civil engineers, this information is new information. For you, is very basic. So my work integrates some branches of search. I use set grammars to model and search domain. My studies in civil engineering to draw and define fictions, and genetic algorithms to search the best solutions. That's some results from typical civil engineering research. This is the best solution just for strength, but impossible to build the shapes in real machines. Another solution for civil engineers too, impossible to build. A more conventional solution, but limited. So, my work was to locate a corpus of feasible solutions, isolate a very simple set of rules. If you have a plate, we can keep this wall the same. We can apply just a single fold. In many cases, it is useful to have a symmetrical fold. To introduce stiffeners of all kinds of stiffener, and implement this in a CAD platform. My first studies uses character, codify these rules by character. Any combination of these parameters results in a feasible solution. I implement this in Rhino because the graphical interface is reliable. But once time we have the code, we transpose this for a CAI software. We have many variables, changing proportion between plates, changing angles. So we transpose this for a Kai software, open source Kai software in MATLAB. Is a kind of finite element method called finite strip method. Instead of small triangles or quads, we have strips. This algorithm provides critical force for buckling in 3 modes: global mode, local mode, distortion mode. Open sections have an unusual behavior, mechanical behavior, almost chaotic behavior. If you change a small proportion, another kind of buckling dominates the process. So the algorithm that I have implemented in Rhino has been implemented in MATLAB. The same algorithm. And can generate all feasible solutions for open sections, still open sections. This program can repeat the process of estimate buckling many times and provide a graphic of feasible strength, feasible solutions for feasible shapes and strength for compression and bending. You have this graphic. This graphic is basically a sensitive graph. If we change proportions, we change the strength of the shapes. And I repeat this process for many kinds of shapes. So engineering is a very useful tool. So we have an optimization for maximum bending, maximum axial strength, and minimum number of foldings. Or the 3 at the same time. It's not perfect too yet, because we have feasible solution on the manufacturer point of view, but it's impossible to assemble them. Okay. My next work is the second stage that I planning with Professor Duarte here in Lisbon. Okay. Now you are working with structures, not isolate members. These structures are designed, of course, under mechanical point of view, but under aesthetic and constructive point of view too. Well, I have to explain these things for civil engineering, okay? For you, not necessary. So I'm sorry. So we have some robust algorithm for optimization, structural optimization, under 2 basic approaches: continuous optimization and discrete optimization. Continuous optimization is basically to add or to subtract material from a continuous domain, taking attention for stress, lower stress, less material. is not usual in civil engineering. It has some application, but it's rare. It's not common. Discrete optimization is very more common approach for civil engineering. Is my approach. There are some grammars for discrete optimization. Some grammars are based in fixed set typologies, and some others are a more rich approach, but offer some additional costs for assembling. My research is intermediate. We're looking for rules using Piet-Mondrian work as base. I isolate a corpus of paintings of Piet-Mondrian. Isolate some rules to generation, rotational symmetry, bilateral symmetry, and golden ratio. And any picture in Piet-Mondrian language is a decision tree. If we change the patch, we achieve another painting of Piet-Mondrian. So I implemented this again in Grasshopper. If we change just one parameter, we have a new painting of Piet-Mondrian. So this is my compositional rules for generated structures. I need now objects. No? The first object is a trapezoidal sheet for collecting water rain. This trapezoidal sheet is inside a trussed beam, and this trussed beam has a roof with planar trusses. That's my objects. The compositional rules is Piet-Mondrian. This is my objects. If we change an object, we have another projective world by the same rules. But scripting in Grasshopper is slow. I need more computational efficiency to work. When this program is already running in Grasshopper, I change my platform. I copy this code and pass in C++ with OpenGL code my program. Now we can distribute this software for enterprise. In Brazil is common. Enterprise specialized in one kind of structure. So we have now independent software that can distribute without Grasshopper, without Rhinoceros. My software can optimize these structures, can proceed a finite element analysis, can show us the more efficient way to distribute the members on their constructive point of view. Okay. This is the stress, and the colored members are the best way to distribute the members on their constructive point of view. And optimize these structures under different goals. We can minimize mass, minimize displacement, and minimize number of joints. Joints is an expensive part of your structures. If you minimize, your structure is cheaper. So we have some experiments. to pursue these things, I have to implement this in C# or C++ or Fortran. Now you are starting a discipline in Unicamp to architects to proceed this kind of things to disseminate this acknowledgement. And the idea is each architect to create your objects like trusses, like beams, like mouse structures. So this code will be shared, and again they will develop rules to assemble these objects. It's starting, but is a discipline for architects interested in structures. We have demand, and the programming skills is hard in Brazil, but we have hope that this selected group will be able to develop this kind of work. Now, what we have.
Thank you very much. It's interesting to see, your digression from architecture into engineering and back to architecture again. So I guess my first question is, tell us a little bit more about the experience of coming back to architecture and teaching structures to architects with all the knowledge that you have acquired in civil engineering.
I'm working with Gabi Celani in a discipline of structure of tall buildings. The first exercise is horrible. My students have no basic understanding of what is a structure. But the final work is beautiful. The evolution is fast. I think there's a special moment in the history, because the separation between architects and engineering is recent, 2 centuries. There is a reason, because the mathematical tools are hard to understand, but computers offer a new stage of this relationship. Because now architects can understand the phenomena. If you understand the phenomenon well understood, the computer can do things for you that 20 years ago are impossible. So we have a chance now to talk with engineers, to create rules and generative systems together to do new things. Is an opportunity. I don't know if you, because the discipline for mixed terms is not possible yet, but you are working in this direction. Mixed terms, civil engineering and architects for programming.
So when students take your course in structures, do you have the feeling that they lack background information?
Yeah. My first phrase in the start, you have to calculate that. Oh, calculate no. Please, no calculus. So I'm not working with calculus. I just working with concepts for a while, because there is no culture for calculus. It's necessary, but there is no culture now. But we have hope, because students that in start point, now I can't, I don't like structures. Please, no structures. At final works, love structures. You have some these students searching for us for more information, for more books, for more programs, for more. There is a gap, but there is a desire to understand more. If you have a good conversation, interesting results are possible. I believe this. I really believe, because we have good results in the first semester that I am working with Gabi at Unicamp in architecture. We have good engineers interested too in the algorithms, in developing products, and assimilate architectural acknowledgement for a new stage of products. But my main work in the research now is still offering softwares for in the industry. On the softwares is here. It's not an architecture, it's just a product. We have now this software can develop, say,
We are not seeing the screen. Sure.
What's happening?
Just have to put the window together.
Olhar para trás, vamos fazer outra coisa.
We can maximize.
No, we can copy. So eu
Maybe-
ponho copiar.
Maybe function.
Exato. Portanto, duplicar. Aparece nos dois lados.
Okay. So this software has been done by a enterprise for roofs, large span roofs in steel structures. You have a single modulus. You can change these modulus. So it's a planar truss. We can apply loads, run the analysis, see the results, like normal force, compression, traction, displacement, and a report with number of members, number of screws. Is a small software for enterprises. It's my main work now. I want to work more with architecture now. I'm working with Gabi. It's possible. We have a protobox here the presentation in Homo Faber has Fab Lab in Campinas. LAPAC. No, LAPAC is the Gabi lab. Protobox is enterprise, and he are working with us for developing new products. So we have some opportunities.
So congratulations for your work, and LAPAC is the first in South America, I would say. The laboratory, so the work is very good. Okay. My question will be more about the civil engineering, because as far as I work here with the engineers in general, the hardest to convince are those from civil engineering in general. They are more suspicious about work. They work more abstract models for perfect solutions. And when at least I talk with some of them, have different solutions. No, why don't you have the same solution for all? Why do you need to make different? So you're opening a new.
Yeah.
You're teaching also the civil engineers. Do you think so?
Yeah, but this is interesting because there are some engineers developing special finite element models for particular cases, and they need a system, generative system, for generate the geometry of these particular cases too. If you work together, we develop special programs for special case. Well,
but you have some engineers that are really interested, but the majority, are they so open to have these new?
No. We have to find them. We have to find them. It's not easy. It's not easy. Now I'm among friends, but not ever in this case.
More questions?
I have a couple of questions, but they were more specific about the exercise, about the prototypes that you showed. So you showed the first prototype in which you applied shape rules to define the profile of
Still open sections.
yes, of how do you say? Section. And then you have the other one with using Mondrian for the design of the structure. I have two questions. One is, are they linked together, or they are two separate prototypes? Two separate exercises?
Now are separate. When you optimize one member, still open sections, you have in medium 20 parameters to optimize. If we are optimizing steel structures, you have more 20 different. So if we have all these parameters in the same program, genetic algorithm is not able to work well. Okay. So at this moment, when I started to work with Professor Duarte, with the owner, you have 3 steps. The first step, optimize just members. Second step, optimize just structures. Last step, optimize all at the same time. But we have more rules to create dependence between all of them to generate feasible, reliable structures with small number of parameters. Yeah, is my challenge now. The last step is my all. We are working in this direction.
The other question would be, because you selected these Mondrian rules, and you are optimizing the design, let's say a Mondrian design, seeing which Mondrian design is more, it's better for structure-wise. Does it have any input concerning the space that is covering, or not? I mean, if the architecture of the building that is going to be covered by that structure is influencing design of the Mondrian design or not, or it's for now it's independent. Or the idea is to go.
First question: why Mondrian?
Because I was outside.
Why Mondrian? Because Mondrian has very simple rules. Okay, this program will be shared with students. Okay, my idea, the architect build rules to optimize a structure. You need 1,000 of evaluations. There is no easy test to conduct this process during the process. You start the process and waiting, and it's not a best best way, but the way what we have now. So my students are stimulated to create more rules, to change objects, and observe the results for a while. Mondrian because it's simple.
Yeah, so you use Mondrian has a simple set of rules.
Yeah.
But it's a placeholder for some other sets of rules that the students or an architect should use for partitioning the space.
Yeah. This is the idea.
Because it's funny because I saw Mondrian, remember the work of Krishna somehow. And you could use his sets of rules to, because it's a different it's a different exactly the scope of using the rules, but it's similar in a way. Same kind of rules. So they could be working together. For now.
Any other questions? So, I never know whether to call it Juarez or Juarez.
In Brazil, Juarez. Follow Gabi Celani recommendation, just J.
Juarez, thank you so much for coming here and presenting.
Thank you very much.
It's nice to see how it's evolving afterwards. I think it was very informative for us, and a lot of things we can talk about.
Thank you very much, Professor.
Thank you all for coming, and have a nice week. Tomorrow, not today.